So we're working with sets, a revisitation of Year 8's work, but it will go a lot further once we start. So a set is a collection of items or numbers that are shown in squiggly curly brackets like that, and the things inside the curly brackets are the members of that particular set, but the technical word for these members are called the elements, highlighted there in blue. So here's an example of what a set could be. So we are Year 9 set 1. Within that set there's a set of boys and a set of girls. So you can imagine how we can subdivide the whole grouping. So here's an important squiggly Greek letter. That's a lowercase x and is used to represent the universal set. So that's all the things, all the elements are taken from that universal set. So if you imagine Year 9 set 1, 14 of us, that is the universal set, and I want to select from that universal set just the girls, or I want to select from that universal set just the boys. So I've got two sets within the entire universe. And you may remember from last year that the universal set is contained within a rectangular box, and the two other sets are shown as circles, and then there's an overlap as well. Okay, so this is an important piece of notation. The union of sets, A and B, for example, two sets that overlap, is represented by A, U, B. And that means all the elements or members which belong to set A or set B or both. All right. So this will become a lot clearer when we do the more advanced questions going forward. But you've got to know that A and B are sets that can be united. There is a union between them. And I'll show you in terms of shading what that looks like. But that's not for today. The intersection of sets of data A and B is written as A intersection B, and that symbol there that I'm highlighting before you is called the intersection, in a similar way that this U that I'm highlighting now is called the union of. So what's A intersection B mean? It means all the elements that belong to both sets. So for example, can't give an example right now. We'll do live examples, when we go forward. This is important, this complement of set A. So A with a little dash, it will be clearer in your textbook than on the video because your textbook's a lot clearer than this. And so the complement of set A means all the elements that do not belong in set A. All right, all the elements that do not belong in set A. So if I've got, for example, Year 9 students, and I've got set Year 9 set 1, all the Year 9 students who are not in our Year 9 set 1 will be outside of that set. All right, so they don't belong in set 1 as a group of students. They belong in a different set, but they're still within the universe of Year 9 students. All right, in our school. So they belong to the wider universe of Year 9, the universal set from which you are taken as a special Year 9 set 1. You're in your own little bespoke group. All right. We've not come across an empty set before. Okay, that could be a set that contains no numbers in it whatsoever. So for example, if I gave you a set of numbers from 1 to 10 inclusive, I said that's the universal set, and I said to you, now list for me all the multiples of 7 greater than 7. Well, the next multiple greater than 7 is 14, but that's outside of the given universe, so that will be an empty set. It doesn't exist. All right. And then they give an example there. I don't like question 1, which is why I didn't set it. It's too many silly words. This was okay, but I didn't want to set it because it's just too much. Remember, this is all to be done within your 55-minute lesson, so I set bite-sized stuff. So Brandon, this is a word to you. I'm setting question 3, question 4, question 5. So here's a live example of where we're going. I've got a universal set of whole numbers from 1 to 40 inclusive. All right, so that's nothing below or above 40 is going to figure in this question. And set A says list me the multiples of 7. So you open up the squiggly bracket and go 7, 14, 21, 28, 35, 42. No, because that's outside the universe. And that's it, Brandon. Then you just close off the bracket. So you've got to find all the sets. All right, there, and just practice doing that. For question 4, the universe goes from 40 to 80. You've got to list the multiples of 6 for set A, the factors of 240, which are drawn from here. Now, don't say 2 is a factor of 240, because the universe starts from 40 upwards. But does 40 go into 240? Yes, 6 fours are 24, so I reckon that goes in 6 times. Use your calculator. I'm going to speed things up. I don't mind you doing that. And for question 5, we have a universal set of whole numbers from 1 to 100. Set A is defined as the square numbers, and set B is defined as the cube numbers. So what's the first square number you can think of? Anybody know? Apart from Tyan. Okay, Tyan, it's over to you. Nobody else wants to get involved because they never do. Tyan, have you disappeared? You might have dropped out because of the internet. T, are you there? Okay, Abraham, join in. I don't know where Tyan's gone at the moment. Yeah, maybe he can't hear. I don't know. Right, so Ibrahim, what's the first square number? What's the next square number? No two numbers multiply together to make 2. So you've got what square number is, Ibrahim. Yeah. The next one. You've missed one out. 3 times 3 is 9. 9's a square number. Okay, so it's so basic, many of you are going to screw up on this big time. Time's back in. Anyway, just be very careful with it. You've got to list all these square numbers. Now, cube numbers, there's less of them, obviously. Anyone know what the first cube number is? There's not a lot of them, I have to say. What's the first cube number? Henry? Yeah, 1, because 1 times 1 times 1 is 1. What's the next cube number?
8.
Yeah, because 2 times 2 times 2 is 8. What's the next cube number?
27.
That's cool. And the next one? And the next one? 125, and we've gone outside the universe. So 125, guys, won't figure in this question. So that's it. I'm deliberately avoiding question 6 because I want to show you what these things actually look like as pictures. I've got them on our Mimeo screen at school, which I can access here as well anyway, but I will download the pictures, crop them, and send you them, because then we've got something good to talk about. But it's really, really, really tricky, and that deserves its own little lesson, which is going to slow us up a bit, but I don't want to hold back, because you're going to meet exactly question 6 in year 11 like that kind of standard, and they've plonked it on us here, and that's it. So I've taken up too much of your time. I apologise for that. So Brandon, one more time, we're going to go home right now. In fact, you're at home now, I guess, and do question 3, 4, 5, and send it to me. I can write it off as done, or I can mark up if it's clearly labelled. Let me just stop the video so I say one other thing.